The history of firearms did not begin with metal or even a bullet. It began with the search for a way to create remote chaos. Over 2,000 years ago in ancient China, a key physical observation was made. When raw bamboo was thrown into a fire, it created a loud bang. This occurred due to the instant boiling of sap and the rapid expansion of air inside the plant's airtight sections. It was this natural explosion that gave the engineers of the past the idea of using internal pressure to strike a target. Stage 1, the bamboo prototype and the fire lance. Around the 10th century AD, the fire lance appeared, a device that effectively became the grandfather of all modern artillery. It was a bamboo tube packed with black powder. However, it is important to understand this was not a firearm in the modern sense. It was a portable, single-use flamethrower. The bamboo tube was tied to a regular spear, and when ignited, it spewed a stream of sparking flames for 2 to 3 meters. The economics of such a weapon were extremely favorable for the armies of that time. Bamboo grew everywhere, and the ingredients for gunpowder, saltpeter, sulfur, and charcoal were relatively cheap. The psychological effect on enemy cavalry, which had never seen harnessed fire, was colossal. Horses panicked and turned back, breaking their own ranks. This was the first step towards stripping the monopoly on killing from professional warrior castes and handing it to the masses. An era began where technology became more important than personal valor. Stage 2, the transition to metal and the birth of the hand cannon. The 14th century brought a technological crisis. The quality of gunpowder was improving, and bamboo tubes began to simply burst in the hands of the shooters, killing them. This forced humanity to transition to the use of metal. The first hand cannons, or handguns, were made of bronze or wrought iron. These were heavy, clumsy devices weighing between 5 to 10 kilograms, resembling miniature cannons lashed to wooden poles. The design was extremely primitive, a metal cylinder closed at one end with a small touch hole on top. The shooter had no stock to compensate for the recoil, so the iron tube was tucked under the arm or its rear portion was braced against the ground. The firing process was a true test of nerves. The shooter could not aim because they had to look not at the enemy, but at the touch hole, where they had to apply a red-hot iron rod or a smoldering wick. A lead ball fired from such a hand cannon could pierce any knightly armor, forever changing the rules of the economics of war. Once the iron tube proved its effectiveness, a new question arose: how to make firearms convenient. By the mid-15th century, a shooter still resembled someone trying to simultaneously hold a heavy stick and avoid getting burned by a glowing wire. It was this technical discomfort that gave birth to the first weapon mechanism in history. Stage 3, the emergence of mechanics and the birth of the arquebus. The 15th century became the starting point for true engineering. The matchlock appeared. It was a simple S-shaped lever, a serpentine that held a smoldering cotton cord. Now a soldier no longer needed to apply the fire by hand. Pressing the trigger caused the lever to smoothly lower the wick into the powder pan. This freed up the hands. For the first time, the weapon featured a developed wooden stock that could be braced firmly against the shoulder. This allowed the shooter to do what was previously impossible: align the eye, the rear sight, and the front sight. Thus, the arquebus was born. From this moment on, war ceased to be chaotic shooting in that general direction. It became a disciplined affair of linear units where every shot was aimed. Stage 4, the evolution of power and the era of muskets. However, the progress of protection did not stand still. Blacksmiths learned to make armor of such quality that a light arquebus bullet would simply ricochet off the breastplate. The response was the musket, a true beast on the 16th century battlefield. It was longer, thicker, and far more powerful. The caliber reached 20 millimeters, and the bullet weighed as much as a modern small chicken egg. The price of this power was colossal. A musket weighed about 9 kilograms. It was impossible to hold it steady for more than a few seconds, so every musketeer carried a furquet, a wooden pole with a rest. The recoil was so strong that soldiers placed leather pads under their clothing to avoid breaking their collarbones. It was during this period that gunsmithing turned into a true state business. Monarchs realized that the winner was not the one with the best warriors, but the one with the best logistics. Standardization began. A uniform caliber meant that bullets from one factory would fit thousands of barrels across the country. This was the first step toward the military-industrial complex we know today. But the main problem remained the dependence on open fire. A single rainstorm could turn an elite regiment of musketeers into a group of people with useless metal sticks. The dependence on a smoldering wick was the primary headache for commanders for 2 centuries. The wick gave away a soldier's position in the dark with its light and smell. It was dangerous near gunpowder supplies, and worst of all, it became useless during the slightest rain. The world needed an autonomous mechanism. Stage 5, the Flintlock and the era of colonial empires. In the 17th century, another engineering breakthrough occurred. The Flintlock appeared. This was the pinnacle of pre-industrial mechanics. Now, a piece of flint was clamped in the cock. When the trigger was pulled, the cock struck sharply against a steel plate, the frizzen. A shower of sparks was struck, falling directly onto the powder pan. This made the weapon truly reliable. The flintlock musket became the primary tool with which European powers redrew the map of the world for 200 years. This was the era of the legendary Brown Bess and Napoleon's muskets. War turned into a business of logistics and reloading speed. Since the smoothbore barrel still did not allow for hitting a person further than 50 meters away, armies formed into dense lines and fired volleys almost at point-blank range. The winner was the one who could fire 3 shots per minute under a hail of enemy bullets. Stage 6, the magic of rifling and the death of linear tactics. For centuries, a bullet rattled inside the barrel like a pea in a jar. This was necessary so that it could be easily rammed down the muzzle, which was often coated in soot from previous shots. However, because of this play, the bullet exited on a random trajectory. The solution came in the form of rifling, spiral grooves inside the barrel. These forced the bullet to spin around its axis, giving it the stability of a gyroscope. In the early 19th century, the emergence of rifles and the minié ball radically changed the rules of the game. Suddenly, the effective aiming range jumped from 50 to 600 meters. This was a technical shock. Generals accustomed to leading soldiers in dense columns wearing bright uniforms suddenly found their units being picked off before they could even see the enemy. Rifled weapons made officers priority targets for the first professional snipers. This killed the romance of old wars and laid the foundation for modern long-distance warfare, where the accuracy of a single marksman carries more weight than the volley of an entire company. Once the rifled barrel provided accuracy, the next obstacle became the speed and reliability of initiating the explosion. The world was still dependent on loose powder on a pan, which could get damp or spill. But in the mid-19th century, high-level chemistry came to the rescue. Stage 7, the percussion cap and Colt revolvers. The invention of fulminate of mercury led to the creation of the percussion cap, a small copper cup that detonated upon a sharp strike. This was the death of the flintlock. Now, the firearm became completely sealed. It was the percussion cap that allowed Samuel Colt to realize the idea of the cylinder. From a business perspective, Colt revolutionized not only design, but also manufacturing. He was the first to implement a system of interchangeable parts. Before this, every rifle was unique, and if a hammer broke, a blacksmith had to custom fit a replacement. With Colt, a part from one revolver fit perfectly into 1,000 others. This allowed a soldier or a colonist on the Wild West to possess previously unseen firepower, 6 consecutive shots without reloading. The firearm ceased to be the handcrafted work of a master and became a mass-produced assembly line product. Stage 8, the Unitary cartridge and Breech-Loading. For 300 years, soldiers loaded weapons through the muzzle, pouring in powder, ramming the bullet with a cleaning rod, and placing the percussion cap. This was slow and dangerous. The soldier had to stand at full height, exposing himself to bullets. The evolutionary leap occurred when all components were combined into a single metal casing. The emergence of the Unitary cartridge allowed for breech-loading from the rear. This radically changed battle tactics. Soldiers were finally able to fire and reload while lying down, hiding behind natural cover. Rifles from the Dries, Mauser, and Mosin systems turned every infantryman into an autonomous killing machine capable of firing 10 to 12 aimed bullets per minute. Stage 9, Recoil Energy and the Maxim gun. Once the cartridge became a sealed metal module, engineers realized that the energy that previously only kicked the shooter's shoulder, recoil, could be used to cycle the mechanism. Hiram Maxim created a system where the weapon itself ejected the casing and chambered the next round. This was an industrial shock. A single machine gun replaced the fire of an entire battalion. War ceased to be a heroic duel and turned into industrial-scale extermination. The business empires of arms manufacturers earned billions from steel monsters that made infantry attacks in open terrain impossible. The era of trench warfare began, where the machine finally became more important than human valor. We have traveled a 3,000-year path, from a bamboo tube that scared enemies with sparks to intelligent systems that see through fog and walls. Today, in 2026, firearms are undergoing their most radical stage of transformation. Stage 10, the intermediate cartridge and the assault rifle. World War II gave birth to the concept of the golden mean. The assault rifle emerged, a weapon that combined the rapid fire of a machine gun with the compactness of a rifle. The legendary AK-47 and the American M16 became icons of an era where mechanical reliability reached its absolute peak. This was a time of simple, raw power that functioned in any conditions. Stage 11, 2026, Smart Weapons and NGSW. Right now, we are witnessing a change in standards. The 5.56mm caliber is becoming a thing of the past because modern ceramic armor has become too strong. Armies are switching to the 6.8mm caliber with hybrid casings. But the main breakthrough is smart optics. A modern rifle is a ballistic computer. It automatically measures wind, distance, and humidity, showing the shooter the exact point of impact. You no longer aim. You merely confirm the shot calculated by the machine. The evolution of weaponry is the story of how technology gradually replaced human error with digital precision. We have reached the peak of mechanics, and now the era of intelligence begins. Thank you for watching. See you in the next episode.